Hello, welcome in this video. Here we will talk a little bit about DNS. We will see uh, what is its purpose, how it works, and some concepts that are related to DNS. Basically, almost everything that is in this slide will be covered. So let's start. So we have this problem here. We are a user. We want to reach YouTube, a destination, but we don't know the address of this resource. We know that in a network, in internet, we need an address to reach a destination. So, little spoiler, DNS is used to answer this question. What is the address of YouTube? Okay, little spoiler. So let's see, just to compare this problem to a real life situation like this. Michael wants to call Holly. What's the number of Holly? Well, let's see our contact list. We look up Holly's number. We have written maybe this number, and we call that number destination. Okay? Well, with DNS is actually pretty the same thing. We don't know the address of youtube.com. We ask the DNS. DNS replies with the address. In this case of the example is an IPv4 address, and we go to that destination. Pretty easy. DNS means domain name system, for the record. So we can say that DNS is like a big address book for the internet. Wow. On the TCP IP stack, it is on the application level. And it is distributed. So we have a bunch of different DNS servers or name servers. That's the same thing. In different geographical locations. It is hierarchical because we will see in the next slides that there is this concept of DNS zones, things like that. This is a very hierarchical concept. And the main purpose is to resolve or to translate domain names into IP addresses. Even the reverse you can do with DNS, okay? Okay, mainly this is the purpose. So we need to make clear what is a domain. Well, a domain is this string separated by dots, and it is composed by a top level domain and a series of other levels that may be added to this domain to identify another resource. Okay, the first one, for example, IT, com, org, net, and so on, is called top level domain, TLD. And then we have other levels up to 5. Okay, this is translated to this concept of DNS zones. Okay, you have this tree, this nice tree, in which you have a root and then other nodes that are responsible for holding other information. So the .com subtree has in its subtree other elements for each domain that falls into the .com subtree, and we can see also the subtree of mysite.it. This is the translation of this v1.test.mysite.it. This is how it looks logically in DNS. So another nice thing is this concept of authoritative name server, which is a special kind of server that holds administrative that holds information about a specific zone. Okay. What are generally the types of name servers? So there is the primary one. A primary name server has the capability to write records. Okay. The secondary is just a replica. Then we have the cache one, which is another subset of a replica of a subset of records. Then we have a forwarder one, which is nice. It is just used to forward queries to other name servers and reply back with the full information. And then the stealth, that we can just say that is a private authoritative name server, okay? each name server holds resource records. Okay, for each domain there is at least one resource record. The most famous or the most important ones are here in this table. Yeah, we won't stay here to explain every one of these because would be pretty boring. But a nice thing to say is that there is this little TTL, time to live, which is the time uh, of which a resource record is considered valid. After this TTL, it may be discarded by the server itself. So you can use this utility NS lookup to query your DNS servers and to find out the results. So this is a query that you do on your default name server. So if you don't specify the DNS server, it will be your default. And you ask for the resource record A, so IPv4, for youtube.com. And this is the reply. So on top, you have the server that you have queried. And then down, you have a non-authoritative answer because it doesn't come from the authoritative name server for youtube.com, but from another name server, and the address. Okay, you can do other kinds of query, for example, mail exchange records, NS canonical name, things like that. Now let's put this answer here. Can two different name servers give different answers? Let's reason about this a little bit before giving out the answer. So, you know, DNS is distributed, okay? Since it is distributed, there are problems, challenges of distributed systems. Namely, there may be sync issues, okay? One server is updated, another server is not yet updated with the most recent information. So yes, they can actually give different answers. So I am querying with another utility called dig right now, youtube.com, and I have on the left one address. Then I do the same query, but specifying a name server 8.8.8.8, which is Google's public DNS, and it gives me another answer, another address. Yeah. So yes, it may happen. It is not a critical problem because yes, it is a different answer, but really those are generally are addresses that identify the same resource. You still land on YouTube. It happens because DNS is distributed. And also it may happen because inside of a server it may happen that there are multiple records of the same type. Okay, it is also used to do a load balancing at DNS levels. So you do a query and you get a result, and another user does the same query but gets another result. So it lands on another server, physical server. So it may be used to offload load to different servers. This is another nice website that you can use to see how different name servers reply to you. It is very, very useful when you are debugging, when you do changes to your DNS zone of maybe your website and you have problems, and you can use this little thing. It's very, very, very useful. Okay, how does name resolution work? We have only said that you ask DNS for things and DNS answers, but how does this really work? Okay, we have a way, iterative way. You ask for your local DNS, what is it.wikipedia.org, and your local DNS does all the dirty work. It may have the record already in its cache, and it may directly reply to you. But generally, it will query the root name server for the .org name server. Then now step number 3 gets the answer. Step number 4, okay, what is wikipedia.org? Okay, and asks the TLD, and so on. At a certain point, it reaches the authoritative name server, which gives that gives the last final answer, and then the local name server replies back to you, step number 8, to with the final answer. Okay, very easy. Then we have the recursive way, which is different. Each name server queries other name servers. Okay, instead of just replying and saying, okay, I finished, boss. No. They query, and there is this chain that gets created, and still at the end you still get your final answer from the first server that you have queried. Okay, here we have some free DNS providers, the big names. You can use Cloudflare 1.1.1.1, Google, and a bunch of other ones. Just an example. Now, another question. Can you have your own DNS server? So instead of using, for example, Cloudflare, you use your DNS inside of your home, maybe on a Raspberry Pi, things like that. Can you do that? Yes, you can do that. You can use something like DNS mask. That is a DNS forwarder, does caching. It can also act as a DHCP server. Yeah. You can use DNS mask, or maybe you can use bind, which is a let's say bigger suite. Okay. Then there are other nice products like the Pi-hole, that defines itself as a DNS sync hole, and they are basically used to do filtering on DNS queries. So the primary use of a Pi-hole or Edguard Home, which is another similar product, is just to have blacklists, also whitelists, so to deny specific domains, maybe for aggressive advertisement, web tracking, and malware, phishing, things like that. Yep. Now, is DNS okay? Or are there some issues? Well, yes. DNS is not encrypted. So every query is clear text. So this makes DNS not secure. Also because this is another problem. A name server, someone could eavesdrop your traffic and manipulate your clear text DNS traffic, and you can't find out. Okay. So DNS is not secure, not encrypted, and also there was this problem of DNS cache poisoning, which was very serious. Okay, a malicious actor could act in such a way that they could manipulate the DNS cache of some servers. So a bunch of intelligent people decided to do something to improve the security of DNS. One thing is Dns Sec. So the purpose is to authenticate records. Okay, so you query a name server, you support DNS Sec, the name server supports DNS Sec, the name server signs the record that gives to you. You can verify the correctness of this signature, and you can verify it. Okay, this record is okay. I'm fine. Okay, if someone manages to tamper this information, you may find out. Okay, this is DNS Sec. Then another thing is DNS over HTTPS, because you know it is, yes, even with DNS Sec, everything is still clear text. So you need something to encrypt it. So DNS over HTTPS is one example. You can also use DNS over TLS, okay? This is an example. It comes from Cloudflare blog. It explains visually in a very easy way how DNS over HTTPS works generally. Okay, it just says, okay, you have an encrypted channel. That's it. Okay. So, what do we know now? Well, we know that DNS is this big distributed hierarchical system that holds mappings between domain names and IP addresses and also other information that we have not talked about. But yes, it's this big address book. There are different record types. By default, it is not really secure, but you can use Dns Sec and DNS over HTTPS to add these 2 layers of security. Okay? So that's it. That's the end of the video. Thank you very much for watching. I hope it is useful in some way. And yeah, thank you.